Good day. My name is Shafronenko Alina, and I want to present you our work named as Credibilistic fuzzy clustering method based on evolutionary approach of crazy wolf in online mode. With my co-authors Yevgeniy Bodyanskiy and Iryna Pliss. The task of classification in the mode of self-learning of multidimensional data is an important part of traditional intellectual analysis. One of the main directions of computational intelligence is the so-called evolutionary algorithm, which are mathematical models of the evolution of biological organisms. The problem of clustering associated with the vector observation often arises in many tasks of intelligent data analysis, such as data mining, dynamic data mining, data stream mining, big data mining, web mining, etc. The most effective are coherent self-organizing maps and evolutionary algorithms, which can improve data clustering in case where data is processed in online modes. From a computational point of view, the problem of clustering is reduced to finding the optimum of multi-extremal functions of a vector argument with the help of gradient procedures, which are repeatedly launched from different starting points. For speed up the process of finding extremes by using the ideas of evolutionary optimization. Evolutionary computation and swarm intelligence are considered the fastest growing algorithms that employ computational intelligence to solve optimization problems. The evolutionary swarm intelligence includes genetic algorithms, biography-based optimizer, evolutionary strategies, population-based incremental learning, genetic programming, and different evolution problem statement. Baseline information for solving the task of clustering in a batch mode is a sample of observation formed from n-dimensional feature vectors x. The problem of fuzzy clustering of data arrays is considered in the condition when the formed clustered arbitrary overlap in the space of features. The source information for solving the problem in an array of multidimensional data vectors formed by a set of vector observation x, where k in the general case the observation number in the initial array. Credibilistic fuzzy clustering method. Alternative to probabilistic and possibilistic procedures, it was introduced credibilistic fuzzy clustering approach, using as its basis the credibility theory and its largely devoid of the drawbacks of known method. The most common approach used in the framework of probabilistic fuzzy clustering is associated with minimizing the goal function. Solution of nonlinear programming problem using the method of Lagrange identity multipliers the leads to the results. The goal function of credibilistic fuzzy clustering has the formula 2. In a batch form, the algorithm of credibilistic fuzzy clustering in the accepted notation can be rewritten as formula 3. And in online mode, when data are fed in real time, you can see on next form. To find the global extremum of function first and 5, it is advisable to use bio-inspired evolutionary algorithm for particle swarm optimization, among which the so-called Great Wolf algorithms can be noted as one of the fastest coding ones. According to the algorithms proposed in 25 gray wolves live together and hunt in groups. This search and hunting progress can be described as follows next forms. If the prey is found, the first dog pursue and approach it. If the prey runs, then the grey wolves chase, surround and watch the prey until it stops moving, which can be rewritten as next formulas. After the prey is found, the attack begins on formula 4. In a case when A bigger than 1, grey wolves flee from domains, which means that omega wolves will flee from more prey and explore more space. In another case, they approach the domains, which means that the gamma wolves will follow the domains that approach the prey. To achieve a proper trade-off between scouting and hunting, and improved Great Wolves algorithm is proposed. The change in the position of the wolves is described as next formulas. To increase the reliability of finding exactly the goal extremum of the objective function, you can use the idea of crazy case optimization, modified by the introduction of a random walk, which has proven the effectiveness when solving multi-extremal problems. By introducing a coordinate rigging and additional search perturbation, it's possible to write down the movement of the wolf in the next form. Experimental research. The proposed method was tested on well-known multi-extremal functions such as a k function presented in the form as you can see on this slide. On the table you can see pseudocode that consists on 3 steps such as step option, initialization, and search. On every step, you can see do next. You can see next data sampling, swarm optimization, control parameters, stop criteria on step setup option. On step initialization, you initial position of the dominant great wolves. On step search, if this not a stop criterion, when the calculation the new value of fitness function, position update, restriction of the position of walls, update alpha, beta, and gamma, and update stop criteria and stop algorithms. For future validation, the searching accuracy of crazy great wolf optimization method with great wolf optimization and pseudo algorithms. Two swarm intelligent algorithms are selected to carry out the simulation contrast the experiments with the proposed crazy great wolf optimization so as to verify its superiority on the convergence velocity and the searching precision. The simulation convergence result on the adopted testing function are shown on the next figure. Conclusion. The problem of credibilistic fuzzy clustering of data using a crazy gray wolf algorithm is considered. The proposed method excludes the possibility of getting stuck in local extrema by means of the double check of finding the domain wolf in the extremum and comparison with the given calculation error. Allows to reduce the number of procedural stats. A feature of the proposed modified optimization procedure is the possibility of managing random disturbances and determine The properties of the modified random walk that has proven effectiveness when solving multi-extremal problems. The approach is quite simple in numerical implementation, allow finding global extrema for complex function, which is confirmed by the results of experimental research. On next slide, you can see a reference on this paper. Thank you for your attention.